Hey everybody, how's it going today? Today we'll be continuing our stoichiometry unit by looking at liquids. Let's dive into it. Get it? Dive? Liquids? Never mind. Today we're going to refresh our understanding of liquids, and I'll even spare you the pun this time. We'll discuss how the density of liquids can be used as a conversion factor, and we'll practice converting volumes of pure liquids into moles. For starters, you should remember from earlier in the year, and probably just from personal experience, that liquids have a fixed volume, but will take on the shape of whatever container they are in. This is opposed to solids, which maintain a fixed shape, and gases, which also take on the volume of whatever container they are in. In chemistry, we deal with a lot of aqueous mixtures, which are not the same as liquid. The main liquid we use in chemistry is water, though ethanol is another common liquid for dissolving organic substances. It's important to distinguish between pure liquids and solutions. A pure liquid is a liquid with nothing dissolved in it. Although it will be fairly rare to get a completely pure liquid, we usually consider anything with a low enough concentration of dissolved substance as pure. Solutions, on the other hand, consist of a liquid with at least one other substance dissolved into it. We'll look more at solutions in the next couple of videos, but today we'll focus on pure liquids. Pure liquids are actually pretty easy to deal with, as we know that 100% of our liquid is only one chemical substance. Liquids are almost always measured in volume, but this is not an ideal unit for converting to moles. Different liquids have different volumes in 1 mole, and this is dependent on both the density and the molar masses of the liquid, as well as the temperature and pressure of the environment. We won't worry too much about temperature and pressure bits here, like we did with gas, but it is worth noting that they can play a role in the liquid volume as well. What we do care about is the density of a liquid, which is measured in grams per cubic centimeter or grams per milliliter. Our most common liquid, water, has a density of 1 gram per milliliter, which makes conversions pretty simple. Let's try some practice converting from volume to mass using density. This first problem asks us how much mass does 2 liters of water that has a density of 1 grams per milliliter have. Now, we need to convert liters to milliliters first. So we have 2 liters times 1,000 milliliters per liter. Liters cancel, equals 2,000 milliliters. Then we can multiply that by the density, which is 1 gram per 1 milliliter. These will cancel out, and we just get 2,000 grams, or 2 kilograms. The second problem is a little more difficult. This one asks, liquid mercury has a density of 13.56 grams per milliliter. What is the mass of 12 milliliters of mercury? So we have 12 milliliters of mercury to start, and we want to end up with mass, which is in grams. Luckily, our conversion, grams to milliliters, so all we need to do is multiply 13.56 grams over 1 milliliter. Milliliters will cancel out, and we will end up with 162.72 grams. Sorry, that kind of got a little bit. And you'll notice that because this is a conversion factor in grams per milliliter, we could also use it to go in the opposite direction. So we could go from mass to volume just by using 1 over whatever the density is. Now that we can calculate the mass of a liquid, converting to moles is the same as it is for solids. We just need to determine the molar mass of our liquid and then use that to convert from grams to moles. We'll try a couple of examples from scratch so you can see how this works. All right. So this first problem asks us, the density of liquid bromine is 3.1 grams per mole. How many moles of bromine are in 45 milliliters? So we start the same way we did last time. We have 45 milliliters, and we want to convert that to grams. So we multiply by 3.1 grams per milliliter. Milliliters will cancel, and that'll leave us with 139.5 grams. Now we need to determine the molar mass of bromine in order to convert that into moles. And the molar mass of bromine is 79.9 grams per mole. Now we are going from grams to moles, so we're going to need to flip this and go times 1 mole per 79.9 grams, which will give us about 1.75 moles. The second problem says ethanol has a density of 0.789 grams per milliliter. How many moles of ethanol are in 700 milliliters? So we start this one the same way. We've got 700 milliliters times 0.789 grams per milliliter, which will give us 552.3 grams. Then we need to use the molar mass of ethanol, which is C2H6O. Remember that when we're calculating molar mass, we're going to need to do 2 times the mass of carbon, 6 times the mass of hydrogen, and 1 times the mass of oxygen. I'm going to round all of these to make it 24 for the carbons, 6 for the hydrogens, and 16 for the oxygen, which will give us a total of 46. So I'm going to do times 1 mole per 46 grams. Grams cancel, and we will get about 12 moles. Let's review. Liquids come in 2 major forms, pure liquids and solutions. While we will most often be dealing with solutions in chemistry, pure liquids can be converted using density and molar mass. We can get the mass of our liquid by using the density and volume, then we can use the molar mass to convert our mass to moles. This makes converting volume to moles a 2-step process. And that's it for this video. In the next lectures, we'll be looking at solutions and the concentration of dissolved substances. I'll see you then.